All right, class, we are in Trig 6.4. So there's two videos for 6.4, one that was done previously, and this one is the missing pieces, so 17, 21, 25, 33. So if you are missing, what, number 15 or 37, refer you back to the previous video. But let's go for it here. So a few little things here just to do beforehand is just to review something called conic sections. So I did spend a little time on this in the classroom here, but conic sections are things that are not functions per se. They're not x and y, but this one's a function, right? Parabolas are functions right here. That's a function still. But I'm going to go sideways as well. So real quick here, let's talk. So circles. Circles are not functions of f of x, but we still use them a lot. So here's a formula for a circle. H and K, notice they're exact opposite signs. So the opposite of H inside the equation becomes the center, and the opposite of K becomes the center of the circle. And there's the radius. Now, for ellipses, this is ellipse. So H and K are still the center. And notice that A and B are over here, and it's set equal to 1 this time. And B is kind of how it stretches vertically, and A is how much it stretches horizontally. So what happens is if A and B are exactly the same, you get yourself a circle. And so what we do is we kind of just multiply through by that the bottom number to get a radius. But if they are different, if B is shorter than A or A is shorter than B, at that point what happens is we write it underneath and we set it equal to 1. And it's just to make things look the same. We're good? So the ellipse and this is called a hyperbola. The ellipse and hyperbola differ by one small thing. Instead of a plus in the middle, they have a minus in the middle. Instead of kind of coming towards each other in a sense, like this right here, these little points coming towards each other, what happens is these points go the exact opposite way. They go out from each other. This is called a hyperbola. Okay, and then this guy's called a parabola. All right, so there's that. What's missing here is the fact that one of them, sometimes x, sometimes h, it's missing the square. If it's missing a square, then it's almost like half of a hyperbola. The other half goes away, and you only get this part right here. And you could have it sideways, you could have it going down, you could have it going to the left or up. So either way, just fine, really. Okay, so anyways, we're gonna do these here on the homework. On the test, I will not require you to say what kind of conic section it is. Okay, so let's go with it. So first things first, number 17. Number 17, here's a setup. You already have it here. So remember, what we have to do is we have to solve for the trig functions here. So x is equal to sine of t minus 2. I'm going to add 2 to both sides. Add 2 to both sides. There, I'm done with this one because I've set it equal to a trig function. The other side, I'm going to add 3 to both sides, and we got ourselves set equal to a trig function. Perfect. So now the question is, which trig formula connects sine and cosine? And you're like, oh yeah, I know that one. It's this one. Absolutely. And so we normally write the cosine first because usually it's the one that actually has the x value. Not always, but usually. And then we write the sine next, even though they could be written first that way or that way, right? So it doesn't really matter. So, but normally cosine deals with the x's, the sine deals with the y's, but not always. So on the homework assignments, you probably should have seen that. Like, what? It's not dealing with that. Absolutely. So notice the x goes first. So not that there's anything wrong, this would be correct on the test, but normally when we write the equation of a circle, we write the x first. So let's move that a little front. The y goes towards the back, and we got it equal to 1. So any which way, that's a correct answer. The y minus 3 to the second, starting that would be a correct answer. You know what? Let me see if I can. Yeah, I should be able to. There it is. Got my pointer. There it is. Okay, so y plus 3, that is a correct answer. That would be accepted on the test for full credit. That would be accepted on the test for full credit as well. This is the standard way of writing it. Oh, you know, I don't have that though. Okay, so this is a circle. This has a circle of radius 1, that little guy right there. 1. Where's the center? The center is -2. It's the opposite of this guy and opposite of this guy. So there it is. Now, do you need to know this stuff for the test? No, you don't. I don't test whether you know conic sections or back to conic sections. Okay, number 21. Here's the setup. And let's go for it. So looking over here, I'm going to add 3 to the other side real quick here. And I'm going to divide by 3 here. Divide by 3 here, divide by 3 here. Notice I'm not showing the work, I just show the next step. And that's fine too. That's normally how it's done. All right, over here, the next step or the next process would be this little guy becomes a minus on the other side. The next step here would be the divide by 3, so that would be the trig function set equal to that. Okay, so which trig function connects sine and cosine? It's this one right here. Cool. All right, and then let's see, we're going to plug it in. So that is, don't forget it's squared, right? Because cosine is squared. That's a linear function. That's a square function. So I got this right here equal to 1. All right, then we got to do a little bit of work here. So first things first is I'm going to square this. So x plus 3 to the second power I'm going to leave alone, just because our conic sections leave it alone, okay? But I am going to square the number on the bottom. So there it is, x plus 3 to the second power over 9. And then we got the x minus 1 to the second power over 9. So now notice these are both the same. So this should look like an ellipse, right? It looks just like an ellipse, except the a and b are exactly the same. The only thing on an ellipse is if a and b are exactly the same, it forms a circle. So we don't leave it in this form. We multiply both sides by that, the same denominator on both sides, and we get ourselves this right here. All right, what does that look like? That is a circle. That is a circle of radius 3. It's always a square root of this little guy right here. All right, what's the center? Center is the opposite of this one, and then the opposite of this one. So positive 1 and done. Dun, da, da, da. 25. Here's a setup. So again, solve for the trig function first. I'm going to divide by 3 over here. Awesome. And that trig function is all by itself now. Okay, let's go over here. Divide by 3 over here. That trig function is all by itself too. Okay, so now the question is there a connection between secant and tangent? Do we know a trigonometric Pythagorean connection between secant and tangent? Yes, we do. It is on your formula sheet and looks something like this. So boom, okay. So it's 1 plus tangent squared theta is equal to secant squared theta. Awesome. So let's move this around to get it the way we want it. So I'm going to move the tangent over to this side. If I do that, I get myself secant squared theta minus tangent squared theta. And I don't like the 1 being equal to on the left. I'm going to take it to the right. And I got myself that. Okay, one more thing that we've got to do. So instead of it being thetas, our trig or our variable is t. So I'm just going to do one more change. I'm going to change this to t's. There it is, just so it looked like exactly what I had before. Okay, here's what we need to do. We're going to plug in x over 3 into this one and square it. We're going to plug in y over 3 into this one and square it. Dun-dunk, dun-dunk, and a 1 on the outside. That's perfect. Okay, so I got y squared is equal to over 9. And that one is giving me that one. Perfect. Okay, so now a few little things here. So the question always comes up is, Mr. Angelo, why don't we just multiply the 9 back into itself right over here? The reason is because we have a minus sign. So it's, if you have an ellipse and if it was a plus sign over here, we would multiply by 9 to get it to look like a circle. We're good? But because it's a 9 and a 9, we leave it just like that because that is the form it takes in terms of a parabola. Ooh, let's see if I can do this. Yep, I think yeah. Show all slides. Back to here. And so, yeah, notice that this one here has a, oh, you know what? I wonder if that works. Oh, nice. So notice this guy has a minus sign here, right? But these two have plus signs. So we want it to look like this because that minus sign being there. That's the thing there. Okay, so let's jam to all slides. Get back to this one here. Okay. Oh, no, we were here. Yeah, and we were done. That's it. This is a hyperbola. All right, center is at 0, 0 because there's nothing subtracting from x and there's nothing subtracting from y. There it is. Okay, and jam to the last one here, number 33. That's what I got here. That's what I got here. And this one's a really interesting one. This one has not cosine and sine. It actually has sine on both of them. Okay, so let's do that. Let's solve for the trig function anyways. Divide by 3, voila. Divide by 2, voila. Okay, so we are a little bit of a problem here. I don't have any trigonometric Pythagorean theorem that connects sine and sine, but I understand that sine is the same thing as sine. So how about this? I'm going to write this one down right here. No, let me do it. Back to laser here. Yep, back to laser. X over 3 comes down. The equal sign comes down. And I'm saying like this. That's sine, but also that's sine. And sine is equal to y over 2. So let's put that y over 2. So there it is. It's called the transitive property. If this is equal to this, and that is equal to this, and these two are equal to each other, therefore the outside are equal to one another. Okay, the only thing is we don't leave it like this. Linear, oh, okay. So this one, notice there's no squares here. These are both linear forms. So let's do this here. Let's multiply across. Let's cross multiply right here. So multiply this guy, gets you 2x. Multiply this guy, gets you 3y. And then normally what we do is we have an x and a y together, linear forms by themselves, solve for y. Isn't this y equals mx plus b? This is y equals mx plus b, mx plus b, then b is equal to 0 technically, right? And so then the answer is this one. It's just just a line. It's a line that goes through 0, 0. It has a slope of 2/3. Okay, so that is the end. That is the end of the homework questions. And hopefully you guys have a wonderful day.